The rule for quadratic functions is a polynomial of degree 2, which you guys all know that. Okay, and the graph of it is what we call a parabola. And we're going to look at all of the aspects of the quadratic function. And we're going to be looking at 3 different forms of it. Problems that you did do some of them on Thursday, should have. Okay. So, reminder that for a quadratic function, we have a vertex, okay, place where it changes directions from either going up or to going down. There are x-intercepts where it crosses the x-axis and y-intercepts where it crosses the y-axis. Okay. And then we have some of them that open up and some of them that open down. How do I know whether it opens up or down or not? Okay, the leading coefficient is positive, it opens up. If it's negative, it opens down. Okay. So it always has a vertex, which is either a max or a min. Has exactly one y-intercept, and it can have 0, 1, or 2 x-intercepts. The parabola is symmetric about a line, which is called that goes through the vertex, called the line of symmetry, or axis of symmetry. Okay. So we have 3 different ways that a quadratic function can be written. The first way is called transformation form, which when we talked about it before in Algebra 2, we talked about it as the vertex form. We talked about polynomial form, when we talk about it before, we talked about it as standard form. And then we have x-intercept form, which we will refer to as factored form. So all of these letters that they use here are all real numbers. And a, you'll notice that a is the one constant in all 3 of them. Okay? That's always the leading coefficient. So if a is positive, it opens up. If it's negative, it opens down. Now, I have written here then all of the different ways or the different things that they tell you. Okay? And these are things that you're going to want to at least put down somewhere to where you have access to them. And we'll talk about each one as we go along. Transformation form or vertex form. A times the quantity x minus h squared plus k. The vertex is the point hk. Okay. And a reminder that if h is positive, okay, and in the equation it's going to say negative h. If h is negative, then it'll say plus in the function. The axis of symmetry is the line x equals h. Okay, the axis of symmetry is a line, it's not just a number. The x-intercepts can be found by using this formula here, which was actually acquired by letting f of x equals 0 and solving it. So basically we did the quadratic formula to find that out, to get this formula for the x-intercepts. And then the y-intercept can be found by doing ah squared plus k. All right, so here's our function. The vertex, axis of symmetry, x-intercepts, and then the y-intercepts. That's transformation or vertex form. And those are all things we've talked about before. The x-intercepts, we haven't really talked about that formula, but most of these should make sense to you. Okay. Then we have polynomial form, which we referred to it before as standard form. Still the value of a is the same. Positive, it opens up. Negative, it opens down. And we've done a lot of work with it from standard form in the past. The axis of symmetry, x equals negative b over 2a. part of our wonderful friend, the quadratic formula. The vertex. To find the vertex, we put negative b over 2a, the x value for the axis of symmetry. Put it back into our function to get the y value for the vertex. Y-intercept is c, as we put 0 in for x, and it would simplify to c. And then to find the x-intercepts, we use the quadratic formula. And the last form is x-intercept, or factored form. In this case, our x-intercepts, or our zeros, are s and t. The axis of symmetry is exactly between them, so we would find the average of s and t to find the axis of symmetry. And then whatever that x value is, we would put that back into the equation or the formula to find the vertex. And then to find the y-intercept, we just multiply a, s, and t together. So when you just look at all three of them differently, there are different things that you see about all of them that they tell you key components right away. When I look at transformation form, right away, I know that from this, I know whether it opens up or down by A, and I know the vertex and the axis of symmetry by looking at them right away. Okay? Vertex is the vertex is HK, axis of symmetry, x equals h. In its polynomial form or standard form, we know two things right away. I know whether it opens up or down by the value of A, and I know the y-intercept. Okay? The other stuff we've got to figure out. Then when we're in x-intercept form, we know whether it opens up or down, and we know what the zeros are. And when we know what the zeros are, we can do a lot of things with that. As far as writing it in the other two forms, if we need to. Because one of the things we're going to be doing is taking it from one form to another. So if we know what it is in x-intercept form, we can find it in polynomial form. Or we could use that to find the vertex form. Either one. Because they all give us enough information to be able to find it in the other form, or simplify it to the other form. Everybody got them? All right, here I showed, and I'm not going to spend any time on this, but showed how to take transformation form to standard form, able to find the zeros. All right, so number one here says for this function, which is in transformation form, it says find the vertex and the x and y intercepts and sketch it. Well, right away, this tells us what the vertex is. Vertex is 2, 5, hk. The value of h is 2 because it's x minus 2, and then plus 5. Then what we want to do to find the x-intercepts and the y-intercepts is just use the formulas that we just went through then. So to find the, let's do y-intercept first. What does it tell us to do for the y-intercept when it's in transformation form? All right, a times h squared plus k. So that means we have to square h first of all, multiply it by a, and then add k to it. So here we've got, it'll be negative 4 times 2 squared plus 5 will give us the y-intercept. So let's see, 4 times negative 4 is negative 16 plus 5 is 11, right? Okay. So we have negative 11. So to graph this, I've got the y-intercept at negative 11, and I know the vertex is at the point 2, 5. How many other points, I know we haven't found the x-intercept yet, but we'll get to that. How many other points do I need? Shelby says I only need one more point. All right. Shelby, what point do I need to graph this then? Okay, the other side of the axis of symmetry. Okay. So the axis of symmetry is here. So since I have the point at 0, negative 11 here, and it's symmetrical, that means I need to just go to the other side of that. So then my other point I need is going to be here. Then I can draw my graph. For a quadratic function, you only need 3 points to draw the graph. The vertex, the y-intercept, and one other one is all you need to draw the graph. Yes, we still need to find the x-intercepts. So what did it say we do to find the x-intercepts? Okay, that's h plus or minus square root of negative k over a, right? Okay, so we just plug in those numbers. Plug in the value of h, which is 2, value of k, which is 5, the value of a, which is negative 4. So our x-intercepts are going to be 2 plus or minus the square root of k, which is 5, and it's negative k over a, right? So if a is negative 4, and I have a negative there already, it's positive 4. So this I could write as 2 plus or minus the square root of 5 over 2, right? Because the square root of 4 is 2. Yep. So basically what we're going to be doing is using all of those things. All right. Number 2. Here we have one in standard form, and they want us to find the vertex, the x and y intercepts, and sketch the graph. Now, if it's in standard form, what's one thing we can do? Okay. Possibly we can factor. If we can, it's a whole lot easier, isn't it? Okay. So let's see. Can I factor this one? X squared plus 4x plus 5? Let's see, the factors are 5 or 1 and 5, and when I add them together, I either get 6 or negative 6, right? Okay. So this cannot be factored, so that doesn't help me, right? Which means that the zeros are not going to be integers. So to find the vertex, we've got to do x equals negative b over 2a, which equals the opposite of 4 over 2 times 1, which is negative 2. What's that? To find, that's the x value for the vertex. To find the vertex in standard form, you have to find negative b over 2a, which tells us what the x value is, and then we have to plug that into the function to find the y value. Right, actually we just found the axis of symmetry is what we did. Okay. So we know the graph has a vertical line through negative 2, which cuts the graph in half. Okay. So our y value then here is negative 2 squared plus 4 times negative 2 plus 5. Which is, let's see, 4 minus 8, negative 4 plus 5 is 1. So my vertex is at the point negative 2, 1. All right, we know what the y-intercept is also, right? What's the y-intercept? 5. Okay. So I have a point at 5. So we know that the axis of symmetry cuts the graph in half at negative 2, right? So if I had to go from here over to here 2 spaces, then I need to go 2 the other way, so that my other point I need to graph is at negative 4, 5. So this graph looks like this, doesn't it? So it does not cross the x-axis, which means there are no x-intercepts. Okay. Third type, x-intercept form. Okay. Well, what do I know right away? Okay. All right, we know the x-intercepts. And those are what? 3 and negative 1, okay? So I've got 3 and negative 1, I have zeros. How's the vertex related to these zeros? Okay, it's got to be in the middle, halfway between them, okay? So what's halfway between negative 1 and 3? Okay, positive 1. So I'll put positive 1 in here. Oops. To find the y value for the vertex. We know the x value is 1. We need to find the y value. So let's see, this is negative 2 times negative 2 times 2. Okay. What's that equal to? 8. Okay. So the vertex is at the point 1, 8. So now I could draw the graph, couldn't I? Okay, I know 3 points. All right. The only other thing is I need to find the y-intercept, right? Okay, when we know the x-intercepts, or it's an x-intercept form, how do I find the y-intercept? Okay. Okay, a times s times c. Now think about that in reality, though, okay? All right. At the x-intercept, or the y-intercept, what's the value of x? 0, right? Okay. So all I'm doing is -2 times -3 times 1, correct? Or I'm doing -2 times 3 times -1. Either way, you're going to end up with the correct answer. Okay. But to find the y-intercept, the x's are 0. Okay. But the formula says just multiply a, s, and t together. So we get -2 times 3 is -6 times -1 is +6. So that'll kind of help me a little bit too, because I know I've got these 2 points here also. So now I end up with 5 points instead of 3. So that will make my graph, hopefully, a little more accurate. So those are the 3 forms of the quadratic functions. Now, number 4 on your sheet says to write the following functions in polynomial and x-intercept form if possible. Okay. Sometimes it's not possible because sometimes we don't have x-intercepts, or they are decimals that don't work very well for putting in. Okay. So letter A. What do I do to write it in standard form, polynomial form? That's the first thing I got to do. I heard distribute. I heard multiply it out. What do you mean, Savannah, when you say distribute? What do I got to do? Right, we got to take care of x minus 2 first. All right, we know that, don't we? That is 0.3 times x squared minus 4x plus 4 plus 5. So we get 0.3x squared minus 1.2x plus 1.2 plus 5, right? Which is 6.2. Now, to write it in x-intercept form, we just need to know the values of a and the zeros, right? Okay. Do we have a way of finding the zeros when we know transformation form? Okay. How do we find the zeros when it's in transformation form? It's on your, wherever you put all that information. Okay. So that is h plus or minus square root of negative k over a. All right. So we get h, oops, the value of h in this case is 2. So we have 2 plus or minus square root of negative 5 over 0.3. 0.3. What's that? Well, currently it's okay because we're just plugging in there. But now, What's the problem here besides that decimal? Okay, square root of negative. Okay, so what does that tell you about the graph? Okay, it doesn't cross the x-axis. Since A is positive, that means it's going to be above the x-axis, so there is no x-intercept form. Okay. All right. Also, it has to be factorable, and that's not factorable either. So, okay. So you would say, so you can't write it in x-intercept form. So your answer would be what we got for polynomial form, 0.3x squared minus 1.2x plus 6.2, and it cannot be written in x-intercept form. I factored out 0.3. So I had to multiply this by 0.7. Or, no, that's not right. I had to multiply it by 10/3. Okay. Let's look at letter B now. Now, for letter B, I want you to take out your calculator. Okay? And I want you to just punch that in your calculator, first of all. Yep, in your y equals. So we know right now that if I put it in either the other two forms, we would have g of x equals either 2 times x minus h squared plus k, or g of x equals 2 times x minus s times x minus t. So we know where the 2 goes, right? In either case. All right, so you just graphed it. What does that graph tell you? Okay, it tells you where the zeros are. Does it tell you where something else is? It'll tell you where the vertex is also, right? Okay, so let's focus on the zeros first of all. What are the zeros? Are they really nice numbers? Okay. Negative 2.5. And what? Is that exact or is that rounded? That's exact? Okay. All right. So then I could write this as 2 times x plus 2.5 and x minus 5.4, right? Okay, so what's the vertex? Really? That's what you got for the vertex? Negative 1.45. Okay. All right. All right. So if we know that the vertex is at negative or positive 1.45. Okay, so it would be x minus 1.45, that quantity squared, and then negative 31.205. Okay, all right. You can look at it in your calculator, or you can use this information here. Okay. 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 So if it was in, what form was this in to start with? Polynomial, right? Okay, if it's in polynomial form, to find the vertex, we find negative b over 2a, plug it in, we get a number, and then we know our vertex, so we can put them in for h and k. To find the to put an x-intercept form, do the quadratic formula, plug them in for s and t. And the same if it's in x-intercept form, I'm not going to do this one, but if it's an x-intercept form, to find polynomial form, you multiply it out. To find vertex form, well, I know what the zeros are, 6 and negative 1. The x value for the vertex is halfway between them, and I just need to plug that number in, and it'll give me the y value for the vertex. And so if you did this one, you would get, there it is in polynomial form. Of course, it didn't ask you for transformation form, but we do it. So for any others that you did, if you did 5a, here's transformation form for 5a. This is all manual calculations with no technology in your hand. We would find the value of h, first of all, by doing negative b over 2a, because that's the x-coordinate for the vertex. And then we would find the value of k by taking that number, which was 3/5, and put it in for x. And we would find the y value, which is 4/5. And then for letter B, to put in transformation, well, the zeros are at 3, -2. Okay. So h for the vertex is the average of them, which would be 1/2. Then to find k for the vertex, we put in 0.5 for x and find the y value. And when you do this, okay, these two values here will always be the same. Okay. You did something wrong. Because if I put the zeros in, where's the zero? Or if the x-coordinate for the zero, or for the vertex, is halfway between them, right? Well, if it's halfway between them, it's going to make them be the same. So, okay. And whatever that number is, what is that number? 1.25, right? So we would say that g of x equals 0.2 times x minus 0.5, because we're going to be consistent, right? Minus 1.25. And there's transformation form. So all three of those forms have specific things that are true about them. It's just a matter of getting it, using those things to get to the zeros, get to the vertex. Find the standard form. All right, let's see what else we got here. Oh, a story problem, and you guys love story problems. Find the dimensions of a rectangular parking lot that can be enclosed with 2,400 feet of fence that has the largest possible area. Now, I'm going to tell you something right now, okay, and don't forget this, okay? It's always, always, always true, right? If you are enclosing something into a rectangle, right? So the perimeter is always a rectangle, and they ask you to find the largest area. The largest area is always going to be it's not going to be a rectangle, it's going to be a square. Okay? Now, if they change one of the sides, if they say it's against a barn or something like that, or a river or something, but if you're using fence to make the whole rectangle, or using something to make the whole rectangle, the largest area will always be a square. Okay? Always happens. So, find the dimensions of the parking lot that be enclosed with 2,400 feet of fence. That's the perimeter is 2,400. So that means that 2L plus 2W equals 2,400, right? That's perimeter. Okay. Area is equal to what? Okay, length times width. So if I want to find the largest area, area is equal to L times 1,200 minus L. Correct? You all right with that? Divide everything by 2. 1,200 equals L plus W. So then W is equal to 1,200 minus L. Okay. So now, to find the largest possible area, now think about it for a second. Okay. This is what kind of a function? What kind of a function is this? What kind of function is that? It's a quadratic, right? If I multiply this out, I'm going to get L squared. Okay? All right, so let's think about this for a second. If I multiplied it out, I get 1,200L minus L squared. Not only is it a quadratic function, but it also looks like what? Is it a happy one or is it a sad one?
Because it's negative 1L squared.
Okay, it's negative 1L squared, so that means it's sad, so that means the graph looks like this, right?
Yeah.
Well, guess where the max is compared to the zeros?
They're the same.
Okay, now think about this just for a second. Let's go back, okay? Let's forget we're dealing with a story problem for a second, okay? All right, because if we do that, all right, let's think about the fact that we're over here somewhere working, okay? What does this right here tell me? What form is that in? L times 1,200 minus L. What form is that in? It's in x-intercept form, right? Okay, is this not x-intercept form? Okay, it is, right? It tells you the zeros, doesn't it? Okay, what are the zeros? Correct, but what are they? Which is what numbers? 0 and 1,200, right? Okay. 0 and this would give me a 0, 0, and this gives me a 0 of 1,200. Okay, you with me now? Okay, what's halfway between them? Okay, so if here's the graph, This is 0. This is 1200. So that means that this number here would be at 600. We're trying to find the 0.
Oh my gosh. No, oh my gosh.
He was thinking about something else. He said it about something else. Okay, so here's my zeros. This in factored form here tells me that the zeros are at 0 and 1200, which means then the max for that parabola has to be halfway between them, or 600. Okay, so let's check this out. Take my calculator. Go to the y equals. Put in x times the quantity, 1200 minus x. And graph it. All right, that's a good graph, isn't it? Okay. Well, this is where I need to understand something. Okay. I need to understand the fact that zeros are between 0 and 1200. So let's go to 1500. And let me graph it now. I have no idea what I had up there. Whew. Apparently my numbers aren't big enough, are they? So we do this. Go to the table. Start at 0. Go by, we have to go to the 1200, right? Second window, table setup. Okay. If we're going up to 1200, would it make sense to go by ones? No.
You go by 12.
Go by 12s? Then we'd have 100 different ones we need to go through. Okay. So we could go through hundreds, go by 50, something like that. Let's try hundreds. And then we can see that at 600, it gives us a maximum of 360,000. So I need to change my window here to 500,000. And then if I graph it, I can see it. Okay. Yeah, it's because the scale's 1 on both of them. Okay. But what happened? Just like I said to start with, if you have a rectangle, you're completely enclosing the rectangle with something, the largest area is going to be a square, because you're going to always going to end up in this situation here where you have 2 zeros that are formulated from the perimeter, okay? And then your max is going to be from halfway between them. All right, so what they want to know, find the dimensions. The dimensions then, it is 600 feet square. Or 600, feet square. Or 600 by 600 feet. All right, we're going to stop there. Okay?